I open my eyes before the sun breaks the horizon, perched on a craggy outcrop 2,000 meters above the valley floor. The air is thin and cold, carrying the scent of pine resin and the faint musk of mammals moving through the undergrowth far below. I am a golden eagle, Aquila crucitus, one of the most formidable avian predators in the northern hemisphere. My scientific name comes from the Latin word for eagle and the Greek word for golden, a reference to the burnished feathers that crown my head and nape. I belong to the family Accipitridae, which includes hawks, kites, and other eagles, and I am placed within the genus Aquila, the so-called true eagles. There are other eagles in this genus, such as the imperial eagle and the steppe eagle, but I am perhaps the most widely distributed and the most studied. My lineage stretches back millions of years, and my ancestors soared over landscapes that have since transformed beyond recognition. I stand roughly 76 to 96 centimeters tall from the tip of my talons to the crown of my head, though this measurement varies by sex and geographic population. Females of my species are larger than males, a pattern common among raptors and known as reverse sexual dimorphism. A female may weigh between 4.5 to nearly 7 kilograms, while a male typically weighs 3 to 5.5 kilograms. My wingspan is one of the most striking aspects of my physical presence, stretching from 180 to 235 centimeters from wingtip to wingtip. This broad span allows me to soar for hours on end, riding thermal currents and updrafts with minimal expenditure of energy. My plumage is predominantly dark brown, ranging from chocolate to nearly black on my back, wings, and tail. But the feathers on my head, nape, and upper neck shimmer with golden and tawny hues when the light strikes them at certain angles. This golden hood is the source of my common name and serves as a visual marker of my identity. Juvenile eagles like myself in the first few years of life display white patches on the wings and a white base to the tail with a broad, dark terminal band, markings that fade as we mature. By the time I reach adulthood, usually around 5 to 7 years of age, my plumage will have darkened fully, and those white patches will have vanished. My beak is a powerful tool, hooked and sharp, colored a dark gray or black with a yellow sear at the base where my nostrils are located. The sear is a fleshy covering that protects the openings to my respiratory system and also plays a role in thermoregulation. My eyes are among the most remarkable features I possess. They are large, forward-facing, and colored a rich brown, providing me with binocular vision that is critical for judging distances when I dive toward prey. The resolving power of my eyes is estimated to be 4 to 8 times greater than that of a human, meaning I can detect a rabbit moving in a meadow from a distance of more than 3 kilometers. This extraordinary visual acuity is made possible by a high density of photoreceptor cells in my retina, particularly in a specialized region called the fovea. I actually possess 2 foveae in each eye, one for forward vision and one for lateral vision, allowing me to track movement across a wide field while maintaining a sharp focus on a single target. My eyes are also equipped with a transparent third eyelid called a nictitating membrane, which sweeps across the eye to keep it moist and clean during flight and protects it when I am tearing into prey. The eyeball itself is relatively immobile in the socket, so I must turn my entire head to shift my gaze, but my neck vertebrae are adapted to allow a high degree of rotation. My legs are feathered down to the base of my toes, an adaptation that provides insulation in cold environments and distinguishes me from some other eagle species that have bare legs. My feet are formidable weapons, equipped with 4 toes, 3 pointing forward and 1 pointing backward, each tipped with a curved black talon. The hallux, or hind talon, is the longest and most powerful, capable of exerting a grip strength measured at over 400 newtons, enough to crush the skull of a mammal or sever the spine of a bird. The bones in my feet are reinforced, and the tendons are arranged in such a way that when I flex my leg, my toes automatically lock into a gripping position. This mechanism allows me to hold onto struggling prey without conscious effort, even during flight. My talons grow continuously throughout my life, and I wear them down through use. But if they become overgrown or damaged, my ability to hunt is severely compromised. Flight is the defining aspect of my existence. My wings are long and broad, with slotted primary feathers at the tips that spread like fingers when I soar. These slots reduce turbulence and allow me to make fine adjustments to my flight path with minimal effort. My wing bones are hollow but reinforced with internal struts, a design that combines lightness with strength. The muscles that power my wings, the pectoralis and supracoracoideus, are anchored to a keeled sternum and make up a significant portion of my body mass. When I need to travel long distances, I use a soaring flight style, circling upward on rising columns of warm air called thermals. Once I reach a sufficient altitude, I glide in the direction I wish to travel, losing height gradually until I find another thermal and repeat the process. This method of travel is highly efficient, allowing me to cover more than 100 kilometers in a single day with relatively little energy expenditure. When I hunt, however, my flight becomes explosive and direct. I can dive at speeds exceeding 240 kilometers per hour, folding my wings partially to reduce drag and extending my talons forward at the last moment to strike. The force of impact is often sufficient to kill prey instantly, though I am also capable of grasping and carrying animals that weigh up to half my own body weight. I rely on my senses to navigate the world and locate prey, and vision is by far the most important of these. My eyes are adapted to detect movement across vast distances, and I can see a broader spectrum of colors than humans, including ultraviolet wavelengths. This ultraviolet vision may help me track small mammals, because the urine trails they leave behind reflect ultraviolet light and stand out against the background vegetation. My hearing is less acute than that of some nocturnal raptors, such as owls, but I can still detect sounds at frequencies useful for locating prey and communicating with other eagles. My sense of smell is generally considered poor, as is typical for most birds of prey, though recent research suggests that some raptors may use olfactory cues more than previously believed. Evidence for this in golden eagles remains limited, and I rely primarily on sight and hearing to interpret my environment. I inhabit a wide range of environments across the northern hemisphere, from the tundra of the Arctic to the deserts of North Africa, from the mountainous regions of Europe and Asia to the open plains and canyon lands of North America. My range is one of the largest of any eagle species, spanning across parts of North America, Europe, Asia, and North Africa. Within this broad distribution, I show a strong preference for open or semi-open landscapes where I can hunt effectively. Mountains, foothills, grasslands, shrublands, tundra, and open coniferous forests are all habitats I commonly use. I avoid densely forested areas where my flight is impeded and where the canopy makes it difficult to spot prey from above. I also avoid heavily urbanized regions, though I occasionally hunt along the edges of agricultural land if prey is abundant and human disturbance is minimal. Within my territory, I require specific landscape features for nesting and roosting. Cliffs are my preferred nesting sites, offering protection from ground predators and a commanding view of the surrounding area. In regions where cliffs are scarce, I may nest in large trees, particularly conifers or hardwoods with sturdy branches capable of supporting the weight of my nest. Some populations have adapted to nest on human-made structures such as transmission towers or artificial platforms erected for conservation purposes, though these are less common. My daily routine is shaped by the demands of hunting and the constraints of weather and daylight. I am diurnal, meaning I am active during the day, and I begin my activities shortly after dawn when the air starts to warm and prey animals emerge from their burrows and hiding places. I spend the early morning hours soaring over my hunting range, scanning the ground below for movement. My hunting strategy depends on the terrain and the type of prey available. In open country, I often hunt by soaring at great heights and then diving steeply toward prey once I have spotted it. In more rugged terrain, I use contour hunting, flying low over ridges and hillsides to surprise prey on the other side. I also employ a sit-and-wait strategy, perching on a high vantage point and watching for activity before launching an attack. Midday is often a time of rest, especially during the heat of summer, when thermal activity becomes too turbulent for efficient flight and prey animals retreat to cover. I may spend this time perched on a shaded rock or a tree branch, preening my feathers and digesting my last meal. Preening is essential for maintaining the integrity of my plumage, which must remain waterproof, insulating, and aerodynamically efficient. I use my beak to realign barbs on each feather and to spread oil from a gland at the base of my tail across the feather surfaces. In the late afternoon, as temperatures cool and prey becomes active again, I resume hunting. I continue this pattern until dusk, when light levels drop and my visual acuity becomes less effective. I then return to a roosting site, often a sheltered ledge or a sturdy branch, where I remain for the night. My diet is diverse and varies significantly depending on geographic location, season, and prey availability. I'm a carnivore and an opportunistic predator, meaning I take advantage of whatever prey is most abundant and accessible. Across much of my range, mammals constitute the bulk of my diet. Lagomorphs, specifically rabbits and hares, are among my most important prey species. In North America, I frequently hunt jackrabbits, cottontails, and snowshoe hares. In Europe and Asia, I take European hares, mountain hares, and various species of rabbits. These animals are well suited to my hunting style because they inhabit open areas where I can spot them from the air, and they are large enough to provide a substantial meal but small enough for me to carry. Ground squirrels, marmots, prairie dogs, and other cereid rodents are also significant prey items in many regions, particularly in mountainous and grassland habitats. In some areas, I prey heavily on ungulate young, including the fawns of deer, the kids of goats, and the lambs of wild and domestic sheep. I am capable of killing animals much larger than myself under certain circumstances, particularly when the prey is young, injured, or weakened. However, I cannot carry these large animals, so I must feed on them where they fall or cache portions for later consumption. Birds also feature prominently in my diet, especially in regions where mammalian prey is scarce. I hunt a wide variety of avian species, from small passerines to large game birds and waterfowl. Grouse, ptarmigan, pheasants, and ducks are common targets, and I have been observed taking geese and even cranes on occasion. I am particularly adept at catching birds in flight, using my speed and agility to intercept them midair. I have also been known to prey on corvids such as ravens and crows, despite their intelligence and wariness. In some coastal and riparian environments, I supplement my diet with fish, though I am not as specialized a fish hunter as the osprey or the white-tailed eagle. I typically take fish that are already dead or dying, stranded in shallow water, or caught by other predators. Reptiles, including snakes, lizards, and tortoises, are consumed in warmer climates, and I occasionally take amphibians or large invertebrates such as beetles and grasshoppers, though these represent a minor component of my diet. Carrion is an important food source, particularly in winter when live prey is scarce or when energetic demands are high, such as during the breeding season. I am not above scavenging from carcasses of animals killed by other predators, by vehicles, or by natural causes, and I will compete with other scavengers such as vultures, coyotes, and other eagles for access to these resources. I am not without enemies. While I am a top predator in many ecosystems, I face threats from other large predators, particularly when I am young or when I am competing for food. Adult golden eagles have few natural predators, but I am occasionally killed by wolves, bears, or large cats such as cougars and leopards, particularly if I am feeding on a carcass on the ground and am caught off guard. Lynxes and wolverines have also been documented killing eagles in certain regions. The greatest threat to my eggs and chicks comes from other avian predators, including other eagles, large owls, ravens, and crows. These birds may raid my nest if it is left unguarded, consuming eggs or young chicks. Mammalian nest predators such as martens, foxes, and raccoons pose a threat in some areas, particularly where nests are located in trees rather than on cliffs. As I grow older and more experienced, my risk of predation decreases significantly, but I remain vulnerable to injury, disease, and starvation, particularly during harsh winters or periods of prey scarcity. Human activity represents the most significant threat to my survival. Historically, I was persecuted extensively across much of my range, shot, trapped, and poisoned by farmers and ranchers who viewed me as a threat to livestock. In some regions, I was hunted for sport or for my feathers, which were used in traditional garments and ceremonies. By the mid-20th century, my populations had declined drastically in many areas, particularly in Europe and the contiguous United States. Legal protections, changes in public attitudes, and conservation efforts have allowed some populations to recover, but I remain vulnerable to a range of human-caused threats. Poisoning, both intentional and accidental, continues to kill eagles in many parts of the world. Lead poisoning from ingesting bullet fragments in carrion or gut piles left by hunters is a major cause of mortality, particularly in North America. Other toxins, including rodenticides and pesticides, also pose risks. Collisions with human-made structures such as wind turbines, power lines, and vehicles cause significant numbers of deaths each year. Electrocution from perching or nesting on power poles is a specific hazard in some regions. Habitat loss and degradation, driven by agricultural expansion, urbanization, and industrial development, reduce the availability of suitable nesting sites and hunting grounds. Disturbance during the breeding season, whether from recreational activities, low-flying aircraft, or other human presence, can cause nest abandonment and reproductive failure. Climate change is an emerging threat that may alter prey availability, shift habitat boundaries, and increase the frequency of extreme weather events that affect my survival and reproduction. I am generally a solitary bird outside the breeding season, though I may tolerate the presence of other eagles at abundant food sources such as large carcasses or concentrations of prey. My social structure is based on mated pairs that form long-term bonds, often lasting for life, though pairs may split if breeding repeatedly fails or if one member dies. Pair bonds are reinforced through a variety of behaviors, including aerial displays, mutual preening, and coordinated hunting. During the breeding season, a mated pair defends a territory that can range from 20 to 200 square kilometers, depending on prey density and the presence of other eagles. Territory boundaries are not fixed and may shift from year to year based on resource availability. I communicate my presence and assert my claim to a territory through vocalizations and visual displays. My calls are varied and context-dependent, ranging from high-pitched whistles and chirps to harsh, grating screams. I am generally less vocal than some other raptors, but I call frequently during courtship, during aggressive encounters with intruders, and when delivering food to the nest. My most common call is a series of sharp, staccato yelps that carry across long distances. I also produce softer, more musical notes during intimate interactions with my mate or when communicating with my young. Visual displays are an important component of my communication repertoire. During courtship, my mate and I engage in spectacular aerial displays that involve steep dives, barrel rolls, and synchronized flight. One of the most dramatic displays is the cartwheel display, in which we lock talons in midair and tumble toward the ground, spinning end over end before releasing and pulling up at the last moment. This display may serve to strengthen the pair bond, to assess each other's fitness, or to advertise our partnership to other eagles. Threat displays are used to deter intruders and include mantling, in which I spread my wings over my prey to shield it from competitors, and a forward-leaning posture with feathers fluffed and beak open, accompanied by aggressive calls. When confronting another eagle, I may engage in aerial combat, striking with my talons and attempting to drive the intruder out of my territory. These encounters can be intense and occasionally result in injury or death, particularly when both birds lock talons and fall to the ground. Reproduction is a complex and demanding process that shapes much of my annual cycle. In most parts of my range, I breed once per year, with the timing of breeding influenced by latitude, altitude, and local climate. In northern regions, I begin courtship and nest building in late winter, with egg laying occurring in March or April. In more temperate regions, breeding may commence earlier, and in desert environments, it may be timed to coincide with the period of greatest prey availability. My nest, known as an eyrie, is a large structure built from sticks, branches, and other woody material. I construct it on a cliff ledge, in a large tree, or occasionally on a human-made structure. The nest is often reused year after year, with each breeding season seeing the addition of new material. Over time, an eyrie can grow to enormous proportions, measuring up to 2 meters in diameter and 1 meter in depth, and weighing several hundred kilograms. The nest cup is lined with softer materials such as grasses, moss, leaves, bark strips, and sometimes green sprigs of vegetation that may have a hygienic or symbolic function. My mate and I both contribute to nest construction and maintenance, though the female typically takes the lead in arranging materials within the nest cup. Egg laying usually occurs within a few days to a week after copulation. The female lays a clutch of 1 to 4 eggs, though 2 eggs are most common. The eggs are white or cream-colored with irregular brown or reddish-brown markings. Each egg weighs approximately 130 to 160 grams and is laid at intervals of 2 to 4 days. Incubation begins with the first egg, leading to asynchronous hatching, in which the chicks emerge at intervals corresponding to the laying sequence. This asynchronous hatching creates a size hierarchy among the chicks, with the oldest and largest dominating access to food. In years when prey is abundant, multiple chicks may survive to fledging, but in years of scarcity, the younger, weaker chicks often die, either from starvation or from aggression by their older sibling, a behavior known as canism or siblicide. This harsh strategy ensures that at least one chick has the best possible chance of survival. The female performs the majority of incubation, rarely leaving the nest during the first few weeks, while the male is responsible for hunting and delivering food. The incubation period lasts approximately 40 to 45 days, varying slightly with temperature and attentiveness. Hatching is a gradual process, with the chick using a specialized egg tooth on the tip of its beak to pip through the shell over the course of 1 to 2 days. Newly hatched chicks are covered in white or pale gray down, are semi-altricial, meaning they are relatively helpless and depend entirely on parental care, and have their eyes open. The female broods the chicks almost continuously for the first 2 to 3 weeks, shielding them from sun, rain, and cold, while the male continues to provide food. The female tears prey into small pieces and offers them to the chicks, which gape and beg for food with open mouths and soft calls. As the chicks grow, their down is replaced by a second coat of thicker, woollier down, and their size increases rapidly. By 3 weeks of age, they are large enough to therm-regulate independently, and the female begins to spend more time away from the nest, often assisting the male with hunting. The chicks grow flight feathers, or juvenile plumage, starting around 4 weeks of age, and by 6 weeks, they are well feathered and beginning to exercise their wings by flapping vigorously while standing in the nest. This wing flapping behavior strengthens the flight muscles and prepares them for their first flight. Fledging, the first sustained flight from the nest, occurs at approximately 65 to 75 days of age, though this varies with food availability and individual development. The young eagle's first flight is often tentative and short, typically a glide from the nest to a nearby perch. Over the following days and weeks, the fledgling becomes increasingly confident and proficient, practicing takeoffs, landings, and maneuvers. The parents continue to provide food for several weeks to several months after fledging, a period known as the post-fledging dependency period. During this time, the young eagle learns to hunt by watching the parents, by trial and error, and by honing its flight skills and coordination. Hunting is not an innate skill, but a learned behavior that requires practice and refinement. Many young eagles die during their first year of independence, unable to secure sufficient food or falling victim to predators, accidents, or starvation. Those that survive this critical period gradually disperse from their natal territory, wandering widely in search of unoccupied habitat, and eventually establishing their own territories and finding mates. I reach sexual maturity at around 4 to 6 years of age, though I may not breed successfully until I am slightly older and have gained sufficient experience and secured a high-quality territory. Once established, I may breed annually for decades. My potential lifespan in the wild is estimated at 20 to 30 years, though some individuals have been documented living longer. The oldest known wild golden eagle was a bird banded in Sweden that lived to at least 32 years of age. In captivity, where I am protected from predators, starvation, and many of the hazards of wildlife, I can live into my 40s or even beyond. Mortality is highest during the first year of life, with estimates suggesting that 50 to 70% of juveniles die before reaching their first birthday. Causes of death include starvation, predation, disease, accidents, and human-related factors. Adult survival rates are much higher, typically exceeding 80 to 90% per year in stable populations, though these rates can be lower in areas with high levels of human persecution or environmental contamination. My movements across the landscape are influenced by season, age, and geographic location. In some parts of my range, particularly at high latitudes or high elevations, I am migratory, moving to lower elevations or more southerly latitudes during winter to escape harsh conditions and reduced prey availability. In other regions, particularly in temperate and desert environments, I am a year-round resident, remaining on or near my breeding territory throughout the year. Juvenile and subadult eagles are more likely to undertake long-distance movements than adults, dispersing from their natal areas in search of food and unoccupied territories. Some young eagles wander hundreds or even thousands of kilometers during this dispersal phase, crossing mountain ranges, deserts, and bodies of water. Migration, when it occurs, is often along well-defined routes that follow mountain ranges, coastlines, or other landscape features that provide favorable winds and thermal uplift. Eagles migrating through certain geographic bottlenecks, such as mountain passes or narrow peninsulas, can be seen in impressive numbers during peak migration periods. These concentrations provide opportunities for researchers to study migration patterns, population demographics, and health status through banding, tagging, and visual observation. I navigate during migration and dispersal using a combination of visual landmarks, the position of the sun, and possibly the Earth's magnetic field, though the mechanisms of magnetoreception in birds are still being studied and are not fully understood. Young eagles on their first migration appear to use an innate sense of direction, often following older, experienced birds or relying on environmental cues such as prevailing winds and topography. Over time, they learn specific routes and stopover sites where food is reliably available. Some golden eagles return to the same wintering areas year after year, demonstrating site fidelity and a capacity for spatial memory. My role in the ecosystem is that of an apex predator, meaning I occupy a top position in the food web and exert significant influence on the populations of my prey species. By hunting and killing prey animals, I help regulate their numbers and may influence their behavior, distribution, and habitat use. Prey species that are subject to predation by eagles often exhibit anti-predator adaptations, such as increased vigilance, use of cover, and altered activity patterns. My presence in an ecosystem can also have indirect effects on other species and ecological processes. For example, by controlling populations of herbivorous mammals such as hares and ground squirrels, I may influence vegetation dynamics and plant community composition. By scavenging carrion, I contribute to nutrient cycling and may reduce the spread of disease by consuming infected carcasses. I also interact with other predators and scavengers, sometimes competing with them for food, and sometimes facilitating their access to carcasses by opening tough hides that smaller scavengers cannot penetrate. I host a variety of parasites and pathogens, including external parasites such as lice, mites, and feather-damaging flies, and internal parasites such as nematodes, cestodes, and protozoans. These parasites are a normal part of my biology and typically do not cause significant harm unless I am weakened by other factors such as malnutrition or injury. I am susceptible to a range of diseases, including avian influenza, West Nile virus, aspergillosis, trichomoniasis, and lead poisoning, which is both a toxicological and a disease-related issue due to its effects on the immune and nervous systems. Diseases can spread through contact with infected individuals, ingestion of contaminated food or water, or through vectors such as mosquitoes. Disease outbreaks can have significant impacts on local eagle populations, particularly when they coincide with other stressors such as habitat loss or food scarcity. My relationship with humans is long and complex, characterized by both reverence and conflict. Across many cultures, I have been regarded as a symbol of power, freedom, courage, and spiritual significance. Indigenous peoples in North America, Europe, and Asia have incorporated eagle feathers, talons, and bones into ceremonial objects, clothing, and rituals. In some cultures, I have been trained for falconry, the ancient practice of hunting with birds of prey. Falconry with golden eagles is particularly associated with the nomadic peoples of Central Asia, where I have been used to hunt foxes, hares, and even wolves. This practice continues today in countries such as Kazakhstan, Kyrgyzstan, and Mongolia, where it is both a cultural tradition and a source of livelihood. In modern times, I have become an emblem of wilderness and conservation, featured on flags, emblems, and currency, and serving as a flagship species for efforts to protect wild landscapes and biodiversity. However, my relationship with humans has also been marked by persecution and conflict. For centuries, I have been viewed by livestock producers as a threat to domestic animals, particularly sheep and goats. Although the extent to which I prey on healthy, full-grown livestock has often been exaggerated, there are documented cases of eagles killing lambs and kids, particularly in regions where wild prey is scarce. This conflict has led to widespread shooting, trapping, and poisoning of eagles, particularly in Europe and North America during the 19th and 20th centuries. In some regions, bounties were paid for dead eagles, and populations were driven to local extinction. Legal protections have been enacted in many countries, prohibiting the killing of golden eagles and providing penalties for violations. These protections have been instrumental in allowing populations to recover, though illegal persecution continues in some areas, often driven by misconceptions about the impact of eagles on livestock and game populations. Conservation status varies across my range. Globally, the golden eagle is classified as least concern by the International Union for Conservation of Nature, indicating that my species as a whole is not currently at risk of extinction. However, this global assessment masks significant regional variation. Some populations, particularly in densely populated or heavily industrialized regions, are small, isolated, and vulnerable to local extinction. In the United Kingdom, for example, golden eagles are largely restricted to the Scottish Highlands, and efforts are underway to reintroduce them to other parts of their historical range. In Japan, the population is small and declining, threatened by habitat loss and human disturbance. In the contiguous United States, my numbers declined dramatically during the 20th century due to persecution and pesticide contamination. But populations have rebounded in recent decades thanks to legal protections and conservation efforts. In parts of Europe and Asia, populations are stable or increasing, while in other regions, trends are uncertain due to lack of monitoring data. Conservation efforts for golden eagles focus on reducing human-caused mortality, protecting and restoring habitat, and mitigating conflicts with human interests. Reducing lead exposure is a priority in many regions, with efforts including outreach to hunters encouraging the use of non-lead ammunition, the establishment of programs to provide free or subsidized non-lead ammunition, and regulations restricting or banning the use of lead bullets in certain areas. Retrofitting power lines to reduce electrocution risk, marking power lines and wind turbines to reduce collision risk, and designing wind energy developments to avoid important eagle habitats are also important conservation measures. Protecting nesting sites from disturbance through buffer zones, seasonal closures of sensitive areas, and public education is essential for maintaining reproductive success. Reintroduction programs, habitat restoration, and research on population dynamics, movement patterns, and threats all contribute to the long-term conservation of my species. There are numerous misconceptions about golden eagles that persist in popular culture and among the general public. One common myth is that I routinely carry off large domestic animals such as full-grown sheep, calves, or even human children. While I am strong and capable of killing animals larger than myself, My ability to carry heavy loads in flight is limited. I can carry prey weighing up to approximately half my own body weight, which means a large female might carry 3 to 4 kilograms, but this is under ideal conditions and for short distances. Carrying a full-grown sheep or calf is physically impossible for me. Documented cases of eagles attacking or attempting to carry off very young lambs or kids do exist, particularly in areas where wild prey is scarce. But these instances are relatively rare and do not represent typical behavior. The idea that I pose a danger to human children is largely a myth, with only a handful of dubious historical accounts and no verified modern cases of golden eagles attacking or carrying off children. Such stories likely stem from misidentification, exaggeration, or cultural folklore rather than actual events. Another misconception is that I have a significant negative impact on game bird populations, leading to conflicts with hunters and wildlife managers. While I do prey on game birds such as grouse and ptarmigan, studies have generally found that my predation does not limit these populations at a landscape scale. Game bird numbers are influenced by a wide range of factors, including habitat quality, weather, disease, and predation by multiple predator species. Removing or reducing eagle populations is unlikely to result in sustained increases in game bird abundance and may have unintended ecological consequences. A related misconception is that I am a major predator of livestock and cause substantial economic losses to ranchers. Research on this topic has produced mixed results, with some studies finding that eagle predation on livestock is rare and economically insignificant, while others have documented localized impacts in specific areas or during specific time periods. The extent of livestock predation appears to depend on factors such as the availability of wild prey, the density of livestock, husbandry practices, and the behavior of individual eagles. In most cases, non-lethal deterrence and improved animal husbandry practices can reduce or eliminate conflicts without the need to kill eagles. A day in my life unfolds according to the rhythms of light, weather, and hunger. This morning, as the first gray light seeps into the sky, I rouse from my roosting spot on a narrow ledge halfway up a cliff face. The night was cold, and frost has formed on my feathers, but my plumage provides excellent insulation, trapping a layer of warm air close to my skin. I stretch my wings, extending them fully to their impressive span, and shake my body to dislodge any ice crystals. I preen briefly, running my beak through the feathers on my breast and under my wings, ensuring that everything is in order. Below me, the valley is still shrouded in shadow, but I can already see the faint outlines of the landscape: the forest, the open meadows, the distant ridges. I launch from the ledge with a powerful downward thrust of my wings, dropping briefly before catching the air and beginning to climb. The air is still cool and dense, and thermals have not yet formed, so I must rely on powered flight to gain altitude. I flap steadily, my wings beating in a slow, deliberate rhythm, each stroke propelling me higher. As I rise above the cliff, the sun breaks over the eastern horizon, flooding the valley with golden light. The warmth feels good on my feathers, and I know that within an hour or two, the sun will heat the ground enough to generate the rising columns of air that will allow me to soar effortlessly. For now, I continue to flap, scanning the ground below with methodical precision. My eyes move constantly, picking out details that would be invisible to most creatures. The flick of a rabbit's ear, the scurry of a vole through the grass, the slow waddle of a marmot emerging from its burrow. I am searching for breakfast, and I am patient. Hunting is not a matter of luck but of persistence, attention, and timing. I fly over a series of rocky outcrops where marmots often sun themselves in the morning. Sure enough, I spot one, a fat individual sitting upright on a boulder, surveying its surroundings. It is alert, but it has not yet seen me. I adjust my course, angling toward the marmot but approaching from an angle that keeps me out of its direct line of sight. I fold my wings slightly and begin a shallow dive, picking up speed. The wind rushes through my feathers and my focus narrows to a single point, the marmot. At the last possible moment, it senses danger and bolts toward its burrow, but I am faster. I extend my legs forward, talons spread wide, and strike with explosive force. My hind talon punches through the marmot's skull, killing it instantly. The impact jars my entire body, but my grip is secure. I flare my wings to break my descent and land heavily on the boulder, mantling over my prey to shield it from any potential competitors. I spend the next several minutes feeding, tearing into the marmot with my beak and consuming the flesh, organs, and bones. I eat methodically, pausing occasionally to scan the sky for other eagles or ravens that might try to steal my meal. Once I have eaten my fill, I leave the remains on the boulder. Other scavengers will find it and benefit from my kill. I preen again, cleaning blood from my beak and talons, and then take flight once more. The sun is higher now, and I can feel the first weak thermals beginning to form. I circle over the valley, rising slowly and settle into a soaring mode. This is the part of the day I find most satisfying. The effortless glide, the panoramic view, the sense of mastery over the air and the land. I am not the only eagle in this valley. My mate is somewhere nearby, likely hunting on the other side of our territory. We have been together for 4 years now, and our bond is strong. We nested this past spring, raising 2 chicks to fledging. Both young are now dispersed, wandering far from here, learning to survive on their own. Our nest sits on a ledge not far from where I roosted last night, a massive structure of sticks and branches that we have added to each year. It is empty now, but we will return to it next spring, repairing and refreshing it in preparation for another breeding attempt. My mate and I do not spend all our time together outside the breeding season, but we remain in contact, often roosting near each other and occasionally hunting cooperatively when the opportunity arises. As the morning progresses, I continue to soar and scan, covering a wide area. I see a herd of deer moving through a clearing, their movements cautious and deliberate. There are several fawns among them, but they are too large now for me to take, and they are closely guarded by the does. I watch them for a moment, noting their location for future reference, and move on. I spot a pair of ravens harassing a coyote that has found a carcass, likely the remains of a deer that died during the previous winter and has been uncovered by melting snow. I consider joining the scavenge, but the coyote is aggressive and the ravens are numerous and noisy. I decide it is not worth the effort and continue my patrol. By midday, the thermals are strong and turbulent, and the sky is dotted with cumulus clouds. I ride the updrafts higher and higher, reaching an altitude where the air is thin and cold. From this vantage point, I can see across multiple valleys and ridges, a domain that spans tens of kilometers in every direction. I am not hungry anymore, so I spend this time simply flying, enjoying the sensation of the wind beneath my wings and the freedom of the open sky. Occasionally, I perform a barrel roll or a steep dive, not for any practical reason but simply because I can. Flight is not just a means of transportation or hunting for me. It is an expression of my nature, a fundamental part of who I am. In the afternoon, I descend to a lower altitude and resume hunting. I have learned over the years where prey is most likely to be found at different times of day and in different seasons. In the late afternoon, rabbits often emerge from cover to feed in the open meadows, and ground squirrels become less vigilant as the day wears on. I focus my search on the edges of the forest, where the transition between trees and open ground creates a rich habitat for small mammals. I spot a jackrabbit feeding in a patch of grass and begin my approach. This time, the rabbit sees me early and flees, bounding across the meadow in long, erratic leaps. I give chase, flapping hard to keep pace, but the rabbit reaches the safety of a thicket before I can close the distance. I pull up and circle back, undeterred. Not every hunt is successful, and I have learned to accept failure as part of the process. I make several more attempts over the next hour with mixed results. I manage to catch a ground squirrel, a smaller meal than the marmot but still useful, and I consume it on a rock outcrop. As the sun begins to sink toward the horizon, I start to think about roosting. I have several preferred roosting sites within my territory, and I choose among them based on weather conditions, proximity to recent hunting areas, and whether my mate is nearby. Tonight, I fly to a tall pine tree on the edge of a ridge, a site that offers a clear view of the surrounding area and protection from the wind. I settle onto a sturdy branch, tuck one leg up into my belly feathers for warmth, and arrange my plumage to retain heat. The sky fades from blue to purple to black, and the stars emerge one by one. I remain still and silent, resting but alert, ready to respond to any disturbance. This is my life, a cycle of flight, hunt, rest, and flight again, repeated day after day, season after season, year after year. The transition from summer to autumn brings changes to my routine and my environment. The days grow shorter, and the temperature drops, particularly at night. The landscape begins to transform as leaves change color and then fall, and the first snows dust the highest peaks. Prey behavior changes as well. Many small mammals begin to prepare for winter, either by hoarding food, putting on fat reserves, or entering hibernation. Migratory birds depart for warmer climates, reducing the diversity and abundance of avian prey. For me, this means I must adjust my hunting strategies and potentially expand my range to find sufficient food. If I live in a region where winters are harsh and prey becomes very scarce, I may migrate to lower elevations or more southerly latitudes. If I am a resident in a more temperate region, I remain on my territory but may shift my diet toward whatever prey is still available, including increased reliance on carrion. Winter is the most challenging season for me, particularly in northern and high-elevation environments. Snow covers the ground, making it difficult for prey animals to move and for me to spot them. Many burrow-dwelling mammals remain underground for extended periods, emerging only briefly when conditions allow. Hunting success rates decline, and I must spend more time and energy searching for food. I become more opportunistic, taking whatever I can find. A winter-killed deer, a rabbit weakened by cold and hunger, a ptarmigan struggling through deep snow. I may also scavenge more frequently, feeding on carcasses that would have been ignored during times of plenty. Competition for food increases as other predators and scavengers also face scarcity. I may encounter wolves, coyotes, foxes, wolverines, and other eagles at carcasses, and these interactions can be tense and occasionally violent. I use my size, strength, and aggression to assert my claim, but I am also pragmatic, willing to wait my turn or to feed quickly and depart if the competition is too intense. Despite the hardships, winter also offers certain advantages. The bare landscape provides excellent visibility, making it easier to spot prey from a distance once it does emerge. The cold weather reduces the activity of flying insects that can be a nuisance during warmer months, and the absence of foliage allows me to perch in trees with an unobstructed view. I also find that some prey species, weakened by the harsh conditions, are easier to catch than they would be during other times of the year. Young, old, sick, and injured animals are particularly vulnerable, and I take advantage of this. My role as a predator during winter serves an ecological function, removing individuals that are unlikely to survive and thereby reducing competition for resources among the remaining population. Spring is a time of renewal and intense activity. As temperatures rise and snow begins to melt, the landscape awakens. Plants send up new shoots, insects emerge, and prey animals become more active. Migratory birds return, and resident species begin their breeding cycles. For me, spring is the beginning of the breeding season, and my focus shifts from survival to reproduction. If I am part of an established pair, my mate and I return to our territory and our nest site. We engage in courtship displays, reinforcing our bond and synchronizing our reproductive physiology. We inspect the nest, repairing any damage from winter storms and adding fresh material to the structure. We copulate frequently, often on or near the nest, and within a few weeks, the female lays the first egg. The period from egg laying through chick rearing is the most demanding time of the year. My mate and I must work together to ensure the survival of our offspring, and this requires cooperation, coordination, and an enormous investment of time and energy. The female incubates the eggs while I, the male, take on the responsibility of providing food. I hunt almost constantly, bringing back prey to the nest multiple times per day. The female rarely leaves the nest during incubation, and when she does, it is only for brief periods to defecate, drink, or stretch her wings. Once the chicks hatch, the demands increase further. The chicks are small and fragile at first, requiring constant brooding and frequent feedings. I continue to hunt, and the female tears the prey into tiny pieces, offering them to the chicks with remarkable gentleness. As the chicks grow, their appetites become voracious, and I must hunt larger and more numerous prey to keep up with their needs. There are days when I am hunting from dawn to dusk, making multiple kills and covering vast distances to find sufficient food. The growth of the chicks is rapid and dramatic. Within a few weeks, they transform from helpless, downy hatchlings into robust, feathered juveniles. Their eyes are bright and alert, their beaks are sharp, and their talons are already formidable. They exercise constantly, flapping their wings and hopping around the nest, building the strength and coordination they will need for flight. I watch them from a nearby perch, feeling a mixture of pride and vigilance. I am aware that this is a vulnerable time, and I remain on guard against potential threats. Other eagles, ravens, and even great horned owls may attempt to raid the nest, and I am quick to drive off any intruders with aggressive displays and, if necessary, physical combat. When the chicks finally fledge, it is both a relief and a source of anxiety. They are no longer confined to the nest, but they are still inexperienced and clumsy. Their first flights are short and awkward, and they often land in precarious locations or on the ground. I continue to provide food for them, delivering prey to wherever they have landed or calling them to a feeding perch. Over the following weeks, they become more confident and capable, learning to follow me on hunting trips and observing my techniques. I do not actively teach them in the way a human might teach a child, but they learn by watching, imitating, and experimenting. They make many mistakes, misjudging distances, missing prey, and occasionally injuring themselves. Some of these mistakes are costly, and not all fledglings survive. Those that do, however, gradually become proficient hunters, and by late summer or early autumn, they are ready to disperse and begin their own independent lives. The dispersal of the young marks a transition for me as well. My parental duties are complete for the year, and I can focus once again on my own needs. My mate and I may remain together on the territory, or we may separate temporarily, each ranging widely to take advantage of seasonal food sources. The bond between us remains, and we will reunite when the next breeding season approaches. In the meantime, I spend my days soaring, hunting, and simply existing in the landscape that I have claimed as my own. This is a time of relative ease, a chance to rebuild my energy reserves and to replace worn feathers during the annual molt. Molting is a gradual process that occurs over several months, with feathers being shed and replaced in a sequence that ensures I always retain the ability to fly. Old, damaged feathers fall out, and new ones grow in, sleek and strong. This renewal is essential for maintaining my flight performance and my overall health. Autumn arrives again and the cycle continues. If I am a migratory individual, I begin to feel the urge to move, driven by changes in day length, temperature, and perhaps food availability. I join other eagles on established migration routes, riding the wind southward or to lower elevations. If I am a resident, I remain on my territory, adjusting my behavior and diet to the changing conditions. Either way, I am shaped by the rhythms of the seasons, the availability of prey, and the demands of survival and reproduction. This is the pattern of my existence, a pattern that has repeated for as long as my species has existed and will continue, I hope, for as long as the wild places where I live remain intact. My interactions with other members of my species are largely limited to my mate and, during the breeding season, to my offspring. Outside of these relationships, I am generally intolerant of other eagles within my territory. However, there are times when I encounter other eagles in neutral areas or at shared resources, and these interactions reveal aspects of my social behavior that are not immediately apparent. At a large carcass, such as a dead elk or a stranded whale, multiple eagles may gather to feed. The dynamics at such a site are complex, governed by a combination of dominance hierarchies, aggression, and opportunism. Larger, older eagles typically dominate smaller, younger ones, and females often dominate males of similar age due to their greater size. Dominance is asserted through threat displays, aggressive postures, and sometimes physical combat. A dominant eagle may mantling over the carcass, spreading its wings wide to prevent others from approaching, or it may lunge at competitors with open beak and outstretched talons. Subordinate eagles wait at the periphery, darting in to snatch morsels when the dominant bird is distracted or temporarily satiated. These feeding aggregations are temporary and dissolve once the food source is depleted, but they provide valuable opportunities for younger eagles to learn social skills and to assess potential mates. Courtship and pair formation often begin at such gatherings, with unmated individuals engaging in displays and interactions that may eventually lead to the establishment of a pair bond. Once a pair is formed, the two eagles typically leave the aggregation and seek out a territory of their own. Territory acquisition is a competitive process, particularly in regions where suitable habitat is limited. Young eagles may spend several years as floaters, wandering without a fixed territory, before they successfully challenge an established pair or find an unoccupied area to claim. This floating phase is a time of high mortality, as these young eagles face food scarcity, predation, and the risks of exploration in unfamiliar landscapes. The importance of territory to my reproductive success cannot be overstated. A high-quality territory provides abundant prey, suitable nesting sites, and minimal disturbance. Eagles that hold such territories are more likely to breed successfully and to raise multiple offspring over their lifetimes. Conversely, eagles relegated to marginal habitats face greater challenges and lower reproductive success. Territory quality can vary widely, even within a small geographic area, and eagles are keenly attuned to these differences. They assess potential territories based on prey density, the presence and condition of nest sites, the proximity of competitors, and the level of human activity. Once a territory is established, it is defended vigorously, and boundaries are maintained through regular patrols, vocalizations, and displays. Intrusions by other eagles are met with swift and aggressive responses, and boundary disputes can escalate into prolonged aerial battles. The social structure of golden eagle populations is thus a mosaic of territorial pairs and non-territorial floaters, with individuals moving between these categories over the course of their lives. This structure has implications for population dynamics and conservation. Territorial pairs produce the majority of offspring, but the floater population serves as a reservoir of potential breeders, ready to fill vacancies when a territory holder dies or disappears. The health of the floater population is therefore an indicator of overall population viability. If the floater pool is depleted due to high mortality or low recruitment, the population may struggle to replace lost breeders, leading to a decline in occupied territories and overall numbers. My ecological role extends beyond my direct interactions with prey and competitors. As a predator, I influence the behavior and distribution of a wide range of species, creating a landscape of fear that shapes how other animals use space and time. Prey species that are vulnerable to eagle predation often alter their behavior in ways that reduce their risk, such as increasing vigilance, avoiding open areas during peak eagle activity, or shifting their feeding times to periods when eagles are less active. These behavioral changes can have cascading effects on the ecosystem, influencing plant communities, insect populations, and the behavior of other predators. For example, if ground squirrels reduce their above-ground activity in response to eagle predation risk, they may spend less time foraging, leading to reduced herbivory on certain plant species and altered vegetation structure. This, in turn, can affect the habitat quality for other species that depend on those plants or on the structural complexity of the vegetation. I also play a role in shaping the evolution of my prey species. Over evolutionary time, populations of prey animals that are subject to eagle predation may develop adaptations that reduce their vulnerability, such as enhanced sensory abilities, cryptic coloration, or behavioral strategies that make them harder to detect or catch. This process, known as predator-prey coevolution, is a driving force in the diversification and adaptation of species. My presence in the ecosystem thus contributes to the maintenance of biodiversity and the functioning of ecological processes. Parasites and diseases are an ever-present aspect of my life, though their impacts are usually subtle and chronic rather than acute. External parasites such as lice and feather mites are common and can be found in my plumage and on my skin. These parasites feed on dead skin, feather material, and sometimes blood. In small numbers, they cause little harm, but heavy infestations can lead to feather damage, skin irritation, and increased energy expenditure due to the need for more frequent preening. I control parasite loads through regular preening and bathing, behaviors that help dislodge and remove parasites and maintain the condition of my feathers. Internal parasites, including various species of worms and protozoans, inhabit my digestive tract and other internal organs. I acquire these parasites by consuming infected prey, and they are a normal component of my gut fauna. Most of the time, my immune system keeps these parasites in check, preventing them from reaching levels that would cause significant harm. However, if I am weakened by starvation, injury, or other stressors, parasite loads can increase and contribute to further decline in my condition. Diseases pose a more serious threat, particularly when they are introduced into populations that have no prior exposure or immunity. Avian influenza, for example, is a viral disease that can cause severe illness and death in birds, including raptors. Outbreaks of highly pathogenic avian influenza have been documented in various parts of the world, and golden eagles are susceptible. West Nile virus, a mosquito-borne virus that affects the nervous system, has caused mortality in raptors in North America since its introduction in the late 1990s. Aspergillosis, a fungal infection of the respiratory system, can occur when I inhale spores from moldy or contaminated environments, and it is often associated with stress or immune suppression. Trichomoniasis, a protozoal infection that affects the upper digestive tract, is typically acquired by consuming infected prey, particularly pigeons and doves. This disease can cause lesions in the mouth and throat, making it difficult for me to swallow and leading to starvation. Lead poisoning, as mentioned earlier, is a major cause of mortality and morbidity in golden eagles, particularly in regions where hunting with lead ammunition is common. Lead is a potent neurotoxin that affects the nervous system, digestive system, and kidneys, and even sublethal exposure can impair my ability to hunt, navigate, and reproduce. The impacts of these diseases and toxins are not always immediately apparent. Chronic low-level exposure to lead, for example, may not cause obvious clinical signs, but can reduce my cognitive function, motor coordination, and immune response, making me more vulnerable to other threats. Similarly, sublethal infections or parasite loads may sap my energy and reduce my body condition, decreasing my chances of surviving a harsh winter or successfully raising young. These chronic, sublethal effects are difficult to detect and study, but they are increasingly recognized as important factors influencing individual fitness and population health. Human activities continue to shape the landscapes I inhabit and the challenges I face. Habitat modification, whether through agriculture, logging, mining, urban development, or infrastructure construction, alters the availability of prey, nesting sites, and suitable foraging areas. In some cases, these changes create new opportunities. For example, agricultural fields may support high densities of certain prey species, such as ground squirrels or voles, and I may benefit from hunting in these areas. However, the overall trend is one of habitat loss and fragmentation, which reduces the carrying capacity of the landscape for eagles and other wildlife. Fragmentation also isolates populations, reducing genetic diversity and making it more difficult for individuals to disperse and find mates. Renewable energy development, particularly wind energy, presents a complex challenge for my conservation. Wind turbines can be a significant source of mortality for eagles and other birds, particularly when they are sited in areas that I use for foraging, migration, or other activities. Collisions with turbine blades can cause instant death or severe injuries. The cumulative impact of multiple wind energy projects across a region can be substantial, potentially affecting population viability. Efforts to mitigate these impacts include careful site selection to avoid high-use areas, seasonal shutdowns during peak migration periods, and the development of detection and deterrent technologies that can sense approaching eagles and temporarily stop turbines or emit signals to encourage birds to avoid the area. These mitigation measures are still being refined, and their effectiveness varies. Balancing the need for renewable energy development with the conservation of eagle populations requires careful planning, ongoing monitoring, and adaptive management. Climate change is an emerging and uncertain threat that may have wide-ranging impacts on my species. Changes in temperature and precipitation patterns can alter the distribution and abundance of prey, shift the timing of seasonal events such as breeding and migration, and affect the suitability of habitats. In some regions, climate change may lead to an expansion of suitable habitat, allowing eagles to colonize new areas or to breed at higher elevations or latitudes. In other regions, it may result in habitat loss or degradation, forcing eagles to move or adapt. Changes in snow cover, for example, can affect the availability of carrion during winter, a critical food source in many northern populations. Earlier springs may lead to mismatches between the timing of eagle breeding and the peak availability of prey, reducing chick survival. Increased frequency of extreme weather events, such as droughts, floods, and storms, can directly kill eagles or destroy nests, and can also have indirect effects through impacts on prey populations and habitat. The long-term consequences of climate change for golden eagles are difficult to predict, but they are likely to be complex and to vary across the species range. Conservation of golden eagles requires a multifaceted approach that addresses the diverse threats I face. Legal protections are foundational, providing the framework for prohibiting killing, harassment, and habitat destruction. In the United States, I am protected under the Bald and Golden Eagle Protection Act and the Migratory Bird Treaty Act, both of which impose strict penalties for violations. In Europe, I am protected under various national and international laws, including the European Union's Birds Directive. These legal protections have been instrumental in reducing direct persecution and allowing populations to recover from historical declines. Enforcement of these laws, however, is often challenging, particularly in remote areas where illegal killing can go undetected. Public education and outreach are essential for building support for eagle conservation and for changing attitudes and behaviors that lead to conflicts. Habitat protection and management are also critical. Designating protected areas such as national parks, wilderness areas, and wildlife refuges provides secure habitat where eagles can nest, forage, and roost without disturbance. Outside of protected areas, land management practices can be adjusted to benefit eagles, such as maintaining open landscapes, preserving or restoring native vegetation, and managing livestock grazing to support healthy prey populations. Nest site protection is particularly important during the breeding season, and this can be achieved through buffer zones that restrict human activities near active nests, seasonal closures of sensitive areas, and cooperation with landowners to minimize disturbance. Reducing human-caused mortality requires targeted interventions. Efforts to reduce lead poisoning include voluntary and mandatory programs to encourage hunters to use non-lead ammunition, such as copper bullets. Studies have shown that non-lead ammunition is effective for hunting and does not pose the same toxicity risks to scavenging wildlife. Retrofitting power poles to reduce electrocution risk involves insulating wires, reconfiguring pole designs, and installing perch deterrents. Marking power lines to make them more visible to flying birds can reduce collision mortality. Addressing wind energy impacts requires collaboration between energy developers, wildlife agencies, and conservation organizations to site projects responsibly, implement effective mitigation measures, and monitor impacts over time. Research and monitoring are essential for informing conservation decisions and for tracking the status of eagle populations. Long-term monitoring programs, including nest surveys, migration counts, and banding studies, provide data on population trends, reproductive success, survival rates, and movement patterns. Satellite telemetry and GPS tracking allow researchers to follow individual eagles over large spatial and temporal scales, revealing detailed information about habitat use, migration routes, and causes of mortality. Genetic studies provide insights into population structure, connectivity, and diversity, helping to identify isolated populations that may be at risk and to inform reintroduction and translocation efforts. Studies of diet, prey abundance, and foraging behavior help identify important prey species and habitats, guiding habitat management and restoration. Research on diseases, parasites, and toxicology improves our understanding of the health threats I face and informs interventions to reduce these risks. Community-based conservation approaches that engage local people in eagle conservation can be highly effective, particularly in regions where human-wildlife conflict is a major issue. Programs that compensate ranchers for livestock losses attributed to eagles, or that provide support for non-lethal deterrents such as guard dogs, fencing, or changes in husbandry practices, can reduce retaliatory killing. Ecotourism and wildlife viewing opportunities can generate economic benefits for local communities and create incentives for protecting eagles and their habitats. Educational programs that highlight the ecological role and cultural significance of eagles can foster appreciation and support for conservation. Indigenous communities, many of whom have long-standing cultural connections to eagles, play a vital role in conservation efforts, bringing traditional knowledge, stewardship practices, and advocacy to the table. Reintroduction and translocation programs have been used in some regions to restore eagle populations to areas where they have been extirpated or to augment small, declining populations. These programs involve capturing eagles from healthy populations and releasing them in target areas, often after a period of captivity, to acclimate them to the new environment. Reintroduction efforts require careful planning, including assessments of habitat suitability, prey availability, and threats, as well as long-term monitoring to evaluate success. In some cases, reintroduced eagles have successfully established breeding populations, while in others, challenges such as high mortality, failure to breed, or emigration from the release area have limited success. Lessons learned from these programs continue to inform best practices and improve outcomes. The future of golden eagles depends on the collective actions of governments, conservation organizations, researchers, landowners, and the public. While significant progress has been made in many regions, ongoing threats and emerging challenges require sustained effort and vigilance. The continued expansion of human populations and infrastructure, the accelerating pace of climate change, and the increasing demand for natural resources all place pressure on the landscapes and ecosystems that eagles depend on. At the same time, advances in technology, science, and conservation practice offer new tools and opportunities for protecting and managing eagle populations. Public awareness of and concern for wildlife conservation are at historic highs in many parts of the world, and this provides a foundation for continued progress. I am a symbol of wild places and of the intricate web of life that sustains them. My survival is intertwined with the health of the ecosystems I inhabit and with the actions of the human communities that share these landscapes. When people choose to protect habitat, reduce pollution, mitigate conflicts, and support conservation, they are not only helping to ensure my future, but also preserving the ecological processes and biodiversity that underpin the well-being of all life on Earth. My presence in the sky is a reminder of the power, beauty, and resilience of nature, and a call to action to safeguard the wild for generations to come. As I soar over the mountains, valleys, and plains that make up my world, I am both an individual and a representative of my species. My experiences, challenges, and triumphs are shared by golden eagles across continents and climates, each navigating the demands of survival and reproduction in their own unique environments. We are shaped by millions of years of evolution, by the landscapes we inhabit, and by the ever-changing relationship between our kind and the human world. We are predators, scavengers, parents, migrants, and survivors. We are creatures of the air, bound to the earth by our need for food, shelter, and mates, but freed by our wings to roam across vast distances and to experience the world from a perspective few other beings can know. This is the story of the golden eagle, a story written in the language of flight, hunt, and survival, and it is a story that continues to unfold every day in wild places around the globe. The sensory world I inhabit is rich and multidimensional, dominated by vision, but enriched by other modalities that help me navigate, communicate, and survive. My visual system is arguably the most highly developed of all my senses, and it is the foundation of my hunting prowess and my mastery of flight. The structure of my eyes is adapted for maximum light gathering and resolution. Each eye is large relative to my skull, occupying a significant portion of the cranial volume. The lens is powerful and can change shape to focus on objects at varying distances, a process known as accommodation. My cornea is also highly curved, contributing to the overall refractive power of the eye. The retina, the light-sensitive layer at the back of the eye, is densely packed with photoreceptor cells, including both rods, which are sensitive to low light levels, and cones, which are responsible for color vision and high-resolution imagery. The concentration of cones is particularly high in the foveal regions, the areas of the retina where visual acuity is greatest. The dual fovea system in my eyes is a remarkable adaptation. The central or deep fovea provides high-resolution forward vision, essential for tracking and striking prey during a dive. The temporal or lateral fovea provides a wide field of view and is used for detecting movement across the landscape while I am soaring. I can switch my focus between these two foveal regions by subtle movements of my head, allowing me to simultaneously monitor a broad area and maintain a sharp focus on specific targets. The temporal resolution of my vision, the ability to detect rapid changes in the visual scene, is also exceptionally high. I can perceive flicker at rates that would appear as a continuous blur to a human, allowing me to track fast-moving prey and to process visual information during high-speed flight. Color vision in golden eagles has been studied through anatomical and behavioral research, and the evidence suggests that I can see a range of colors comparable to or exceeding that of humans. I possess 4 types of cone cells, each sensitive to different wavelengths of light, including ultraviolet. This tetrachromatic vision allows me to distinguish subtle differences in color and pattern that are invisible to most mammals. The ability to see ultraviolet light may aid in prey detection, as mentioned earlier, because the urine and feces of small mammals reflect ultraviolet wavelengths and create trails that stand out against the background. It may also play a role in assessing the condition of potential mates, as plumage quality and coloration can signal health and genetic fitness. The reflectance properties of feathers in the ultraviolet spectrum have been documented in many bird species, and although the role of ultraviolet signals in golden eagle communication is not fully understood, it is likely to be important. My hearing is less studied than my vision, but is nonetheless an important sensory modality. The structure of my ears is typical of birds, with an external auditory opening located behind and slightly below my eyes, hidden beneath feathers. I do not have external ear flaps or pinnae as mammals do, but the feather structure around the ear opening may help to channel sound waves toward the auditory canal. The middle ear contains a single bone, the columella, which transmits vibrations from the eardrum to the inner ear. The inner ear contains the cochlea, the organ of hearing, which is shorter and less coiled than in mammals, but is still capable of detecting a wide range of frequencies. Research on hearing in raptors suggests that I am most sensitive to frequencies in the range of 1 to 4 kilohertz, which corresponds to the vocalizations of many prey species and to the calls of other eagles. My ability to localize sound, to determine the direction and distance of a sound source, is reasonably well developed and may assist in detecting prey hidden in vegetation or in responding to the calls of my mate and offspring. My sense of smell, or olfaction, has traditionally been considered poor in birds of prey, and golden eagles are no exception. The olfactory bulb, the part of the brain responsible for processing smell, is relatively small in raptors compared to other sensory processing areas. However, recent research has challenged the assumption that birds have a poor sense of smell, and there is growing evidence that some species use olfactory cues for navigation, foraging, and social interactions. Whether golden eagles use smell in any significant way remains uncertain. I have not been observed to engage in behaviors that clearly indicate reliance on olfaction, such as sniffing the ground or investigating scents in the air. It is possible that I have a functional sense of smell that is used in subtle or context-specific ways, but if so, it is likely to be far less important than vision and hearing. My sense of touch is mediated by receptors in my skin, particularly in my feet, beak, and the base of my feathers. These receptors provide information about pressure, texture, temperature, and pain. The sensitivity of my feet is important during prey capture and handling, allowing me to assess the size, shape, and condition of the animal I have grasped, and to adjust my grip accordingly. The beak is also a tactile organ, equipped with receptors that help me manipulate food, preen feathers, and explore objects. The feathers themselves contain mechanoreceptors at their bases that detect displacement and vibration, providing feedback about airflow, wing position, and external contact. This tactile information is integrated with visual and proprioceptive inputs, the sense of body position and movement, to produce the coordinated motor actions required for flight, hunting, and other behaviors. Proprioception is essential for my ability to execute complex and precise movements, such as adjusting wing position during a dive or extending my talons at the exact moment of impact with prey. Proprioceptive receptors are located in my muscles, tendons, and joints, and they continuously send information to my brain about the position and movement of my limbs and body. This sensory feedback loop allows me to make rapid and automatic adjustments to my motor commands, ensuring that my movements are smooth, accurate, and adaptive. The cerebellum, a part of my brain located at the base of the skull, plays a central role in processing proprioceptive information and coordinating movement. Damage to the cerebellum or disruption of proprioceptive signaling can result in ataxia, a loss of motor coordination, which would be fatal for a bird that depends on flight for survival. My brain is relatively large for a bird, reflecting the cognitive demands of my lifestyle. The cerebrum, particularly the regions involved in sensory processing and motor control, is well developed. The optic lobes, which process visual information, are especially large, consistent with the importance of vision in my life. The hippocampus, a region associated with spatial memory and navigation, is also prominent, which is not surprising given the need to remember the locations of nests, prey concentrations, and territory boundaries across a large and complex landscape. Studies of avian cognition have revealed that birds, despite their different brain structure compared to mammals, are capable of sophisticated behaviors, including problem-solving, tool use, social learning, and even elements of what might be considered planning and reasoning. While research on golden eagle cognition is limited, observations of my behavior suggest a high degree of intelligence and adaptability. For example, I have been observed using cooperative hunting strategies with my mate, coordinating our attacks to drive prey into a vulnerable position, or to take turns harassing prey until it is exhausted. This behavior requires communication, coordination, and an understanding of the roles and actions of both individuals. I have also been observed using terrain to my advantage, such as approaching prey from behind a ridge to avoid detection, or using the sun's position to blind prey during an attack. These tactics suggest an ability to assess the environment, anticipate the behavior of prey, and adjust my strategy accordingly. In captivity, golden eagles have been trained to perform complex tasks, respond to commands, and even recognize individual humans, demonstrating a capacity for learning and memory that rivals that of many mammals. My cognitive abilities extend to social learning, the acquisition of information by observing the behavior of others. Young eagles learn to hunt not through direct instruction, but by watching their parents and later, by observing other eagles. They pay attention to what prey is being targeted, how it is approached, and what techniques are successful. They then attempt to replicate these behaviors, refining their skills through trial and error. This form of learning is highly efficient, allowing young eagles to acquire complex skills more rapidly than if they had to discover everything on their own. Social learning may also play a role in other aspects of my life, such as migration routes, foraging locations, and responses to human disturbance. If I observe other eagles avoiding a particular area or exhibiting alarm behaviors, I may learn to avoid that area as well, even if I have not directly experienced the threat. The capacity for behavioral flexibility and innovation is another hallmark of intelligence, and golden eagles exhibit these traits in various contexts. I have been documented hunting a wide variety of prey species, using different techniques depending on the situation. I have adapted to human-altered landscapes, exploiting new food sources such as roadkill and agricultural pests. I have learned to avoid certain threats, such as power lines and wind turbines, at least to some extent, through experience or social transmission. This behavioral plasticity is crucial for survival in a rapidly changing world, where traditional habitats and prey may be disappearing, and new challenges are constantly emerging. The relationship between intelligence, brain size, and behavior is complex and not fully understood. While brain size relative to body size, a measure known as the encephalization quotient, is often used as a proxy for cognitive ability, it is clear that brain structure and the organization of neural circuits are also critically important. Birds have evolved a different brain architecture than mammals, with dense clusters of neurons in regions such as the pallium, which is analogous to the mammalian cortex. This compact organization allows for efficient neural processing and may underlie the remarkable cognitive abilities observed in many bird species. Golden eagles, with their large brains, sophisticated sensory systems, and complex behaviors, are likely among the more cognitively advanced avian species, though much remains to be learned about the inner workings of my mind. My daily and seasonal movements are influenced by a complex interplay of internal and external factors, including circadian rhythms, seasonal changes in day length, weather conditions, prey availability, and social dynamics. Circadian rhythms are endogenous cycles that regulate physiological and behavioral processes over a roughly 24-hour period. These rhythms are driven by a biological clock located in the brain, specifically in a region called the suprachiasmatic nucleus in mammals and an analogous structure in birds. The clock is synchronized to the external environment by cues such as light and temperature, ensuring that my activity patterns are aligned with the day-night cycle. My circadian rhythm dictates that I am active during the day and rest at night, and it influences a wide range of processes, including body temperature, hormone secretion, and metabolism. Seasonal changes in day length or photoperiod are a critical cue for timing annual events such as migration, molt, and reproduction. As days grow shorter in the fall, hormonal changes are triggered that prepare me for migration or for the metabolic adjustments needed to survive winter. As days grow longer in the spring, reproductive hormones are activated, initiating courtship, nest building, and egg laying. The precise mechanisms by which photoperiod influences these processes involve the detection of light by photoreceptors in the brain, which then signal to the pineal gland and the hypothalamus, structures that regulate hormone production. The interplay between circadian rhythms, photoperiod, and other environmental cues ensures that my behavior and physiology are appropriately timed to maximize survival and reproductive success. Weather conditions have immediate and direct effects on my behavior. Wind speed and direction influence my flight energetics and my hunting success. Strong headwinds make flight more costly, while tailwinds can facilitate long-distance travel. Thermal activity, which depends on solar heating of the ground, determines my ability to soar efficiently. On overcast or rainy days, thermals are weak or absent, and I must rely more on powered flight, which is energetically expensive. Precipitation can also reduce visibility and make it harder to spot prey, leading me to reduce my hunting activity or to shift to alternative strategies such as perch hunting. Temperature affects my thermoregulatory demands and the activity patterns of my prey. On very hot days, I may become less active during midday to avoid overheating, while on very cold days, I must increase my food intake to maintain body temperature. Extreme weather events such as blizzards, heat waves, or storms can pose serious threats, forcing me to seek shelter, fast for extended periods, or expend extra energy to survive. Prey availability is perhaps the most important determinant of my movements and distribution. I am an opportunistic predator, and I concentrate my activities in areas where prey is abundant and accessible. Seasonal changes in prey populations, such as the breeding of ground squirrels or the migration of waterfowl, create pulses of food availability that I exploit. I may shift my hunting range or even my territory boundaries in response to these changes. In some cases, I may move long distances to track seasonal prey resources, such as following the migration of caribou or the emergence of juvenile ungulates. My ability to locate and exploit these ephemeral food sources is a testament to my cognitive abilities, my mobility, and my adaptability. Social dynamics also influence my movements, particularly in the context of territory defense, mate acquisition, and interactions with other eagles. During the breeding season, I spend most of my time within my territory, patrolling the boundaries and guarding the nest. Outside the breeding season, territorial boundaries may relax, and I may range more widely, overlapping with the ranges of other eagles. Encounters with conspecifics can be cooperative, neutral, or antagonistic, depending on the context. At a shared food source, I must balance the benefits of feeding with the costs of competition and the risk of injury. In the presence of a potential mate, I may engage in displays and courtship behaviors. In the presence of a rival, I may engage in aggressive interactions. These social interactions shape my spatial behavior and influence my decisions about where to go, when to stay, and when to leave. The mechanics of my flight are a marvel of biomechanical engineering, the result of millions of years of evolution refining the avian body plan for aerial locomotion. My wings are modified forelimbs, with bones, muscles, tendons, and feathers arranged in a configuration that generates lift and thrust. The primary feathers, attached to the hand bones, are long and stiff, and they provide most of the propulsive force during flapping flight. The secondary feathers, attached to the ulna bone of the forearm, contribute to lift and help form the airfoil shape of the wing. The tertiary feathers, attached to the humerus bone of the upper arm, smooth the airflow between the wing and the body. The alula, a small group of feathers attached to the thumb, can be deployed at low speeds to prevent stalling by directing airflow over the wing. The shape and structure of my feathers are critical to their aerodynamic function. Each feather consists of a central shaft, or rachis, from which branches called barbs extend. The barbs, in turn, have smaller branches called barbules, which interlock with the barbules of adjacent barbs via tiny hooks called barbicels, creating a smooth, continuous surface. This interlocking structure makes the feather strong, flexible, and resistant to air leakage. The feathers are coated with oils secreted from the uropygial gland at the base of my tail, which waterproofs them and helps maintain their structure. Damage to the feather structure, whether from wear, parasites, or injury, can degrade aerodynamic performance and increase the energy cost of flight. Lift is generated by the movement of air over the curved upper surface of the wing, which travels faster than the air passing under the wing, creating a pressure difference. This pressure difference produces an upward force that supports my weight. The amount of lift depends on the speed of airflow, the angle of attack of the wing area, and the air density. Thrust is generated by the flapping motion of the wings, which pushes air backward and propels me forward. The downstroke, powered by the large pectoralis muscle, generates most of the thrust, while the upstroke, powered by the smaller supracoracoideus muscle, returns the wing to its starting position. The wings are not simply flapped up and down, but move through a complex three-dimensional path that varies depending on flight mode. During slow flight or takeoff, the wings are flapped with a large amplitude and a steep angle of attack, generating maximum lift and thrust. During fast flight, the wing movements are more rapid and shallow, and the angle of attack is reduced. During soaring, the wings are held relatively still, and I rely on rising air currents to provide lift, making only small adjustments to wing position and shape to maintain altitude and direction. The tail plays an important role in flight stability and control. It acts as a rudder, allowing me to steer by tilting it left or right, and as an elevator, allowing me to pitch up or down by adjusting its angle. The tail also increases lift during slow flight and landing by increasing the effective wing area. The shape of the tail can be changed by spreading or closing the tail feathers, which alters its surface area and aerodynamic properties. The musculature and skeletal structure of the tail are adapted for fine control, allowing me to make rapid and precise adjustments during maneuvering flight. My body is streamlined to minimize drag, the resistance to motion through the air. The feathers lie flat against the body, creating a smooth contour, and the body shape is fusiform, tapering toward both ends. My legs are tucked against my body during flight, further reducing drag. The bones of my skeleton are lightweight but strong, with many bones being hollow and reinforced with internal struts. This reduces the overall mass of the skeleton, leaving more weight capacity for muscles, organs, and energy stores. The respiratory system of birds is also highly efficient, with a system of air sacs that allows for continuous, unidirectional airflow through the lungs, maximizing oxygen extraction. This is particularly important during high-intensity activities such as gas-powered flight and during high-altitude soaring, where the air is thin and oxygen is less available. The energetics of flight are a major constraint on my behavior and ecology. Flight is energetically expensive, particularly powered flight, which can require 10 to 20 times the energy expenditure of resting. Soaring flight is much more economical, requiring only slightly more energy than resting, because I am using external energy sources, the movement of air, to stay aloft. My ability to find and exploit thermals, updrafts, and other air currents is therefore critical for minimizing the energy costs of flight and for extending the distances I can travel. I have learned through experience where thermals are likely to form, such as over sun-heated slopes, dark-colored fields, or areas with little vegetation. I also watch the behavior of other soaring birds, such as vultures and other eagles, and I join them when I see them circling upward, indicating the presence of a thermal. The energy required for flight must be obtained from the food I consume, and this creates a direct link between my foraging success and my mobility. If prey is scarce and I am unable to obtain sufficient food, my body condition declines, and I have less energy available for flight. This can create a negative feedback loop, where reduced flight capacity makes it harder to hunt, leading to further energy deficit. Young eagles, which are less experienced and less efficient hunters, are particularly vulnerable to this dynamic, and starvation is a leading cause of mortality during the first year of life. Adult eagles, with their greater experience and established territories, are better able to buffer against short-term food shortages by drawing on fat reserves and by shifting to alternative prey or foraging strategies. Thermoregulation, the regulation of body temperature, is another important aspect of my physiology. Birds are endothermic, meaning we generate heat internally through metabolic processes, and we maintain a relatively constant body temperature despite changes in environmental temperature. My normal body temperature is around 40 to 42 degrees Celsius, which is higher than that of most mammals. Maintaining this high temperature requires a continuous supply of energy, particularly in cold environments. I have several adaptations for conserving heat, including dense feather insulation, countercurrent heat exchange systems in my legs that reduce heat loss through the extremities, and behavioral strategies such as fluffing my feathers to trap more air, tucking my head and feet into my plumage, and huddling in sheltered locations. In hot environments, I face the opposite challenge of dissipating excess heat to avoid overheating. I do this by panting, which involves rapid breathing to increase evaporative cooling from the respiratory tract, by gular fluttering, which is rapid vibration of the throat and mouth lining to increase evaporation, and by seeking shade and reducing activity during the hottest parts of the day. I can also urinate on my legs, a behavior called urohydrosis, which cools the legs and feet through evaporation, though this behavior is more common in some other bird species and is not extensively documented in golden eagles. Water balance is closely linked to thermoregulation and osmoregulation, the regulation of salt and water balance in the body. I obtain most of my water from the prey I consume, as the tissues of mammals and birds contain a high percentage of water. I also drink from streams, ponds, and other water sources when they are available. Water loss occurs primarily through respiration, evaporation from the skin and respiratory tract, and excretion in feces and uric acid. Birds excrete nitrogenous waste primarily in the form of uric acid rather than urea, which is the primary nitrogenous waste product in mammals. Uric acid is relatively insoluble and can be excreted as a semi-solid paste with minimal water loss, an adaptation that conserves water. The excretory system consists of the kidneys, which filter the blood and produce urine, and the cloaca, a common chamber that receives input from the digestive, urinary, and reproductive tracts, and from which waste is expelled. I do not have a urinary bladder, so urine is not stored but is excreted continuously or at frequent intervals, often mixed with feces and the whitish droppings characteristic of birds. The digestive system is adapted for processing a carnivorous diet. My esophagus is a muscular tube that transports food from the mouth to the stomach, and it is expandable, allowing me to swallow large pieces of meat and even whole small prey items. The stomach consists of two chambers, the proventriculus, which secretes gastric acid and digestive enzymes, and the ventriculus or gizzard, which is a muscular organ that mechanically grinds food. In many birds, the gizzard contains grit or small stones that aid in grinding, but in raptors, which consume primarily soft-bodied prey, the gizzard is less muscular and relies more on the chemical digestion initiated in the proventriculus. The small intestine is where most nutrient absorption occurs, and it is relatively short in raptors compared to herbivorous birds, reflecting the high digestibility of animal tissues. The large intestine is also short, and it functions primarily to absorb water and electrolytes. Digestive waste, along with uric acid from the kidneys, is expelled through the cloaca. A distinctive feature of raptors is the production of pellets, compact masses of indigestible material that are regurgitated after a meal. Pellets consist primarily of fur, feathers, bones, and other hard parts that cannot be digested. The formation of pellets occurs in the gizzard, where these materials are compressed into a compact mass. After several hours, the pellet is regurgitated, typically in the morning before the first feeding of the day. Pellets are often found beneath roosting or perching sites, and they are valuable to researchers because they provide information about diet and prey species. By examining the contents of pellets, scientists can identify the types of animals I have been eating, the relative proportions of different prey species, and even seasonal or regional variations in diet. Pellet analysis has been used extensively in studies of golden eagle ecology and has contributed significantly to our understanding of my feeding habits and ecological role. My reproductive biology is characterized by a high degree of parental investment, slow maturation, and long lifespan. These traits are typical of what ecologists call a K-selected life history strategy, which is associated with stable environments, low mortality rates, and intense competition for resources. K-selected species, in contrast to R-selected species that produce many offspring with little parental care, invest heavily in each offspring, ensuring that they have the best possible chance of surviving to reproductive age. For golden eagles, this strategy makes sense given the demands of the environment I inhabit. Nesting sites and high-quality territories are limited, and competition for these resources is intense. By investing heavily in a small number of offspring, and by forming long-term pair bonds, I maximize the likelihood that my genes will be passed on to the next generation. The formation of pair bonds is a complex process that involves assessment of potential mates, display behaviors, and mutual testing of compatibility and fitness. Eagles are monogamous, at least for a breeding season and often for life, and the pair bond is maintained through repeated interactions and shared experiences. Courtship displays are elaborate and spectacular, involving aerial acrobatics such as sky dancing, in which the pair soars together, performing synchronized twists, turns, and dives. The cartwheel display, in which the pair locks talons and tumbles through the air, is thought to be both a courtship ritual and a test of strength and coordination. These displays serve multiple functions. They allow each bird to assess the quality of the other as a mate. They synchronize reproductive physiology through visual and possibly hormonal cues. And they reinforce the pair bond through shared activity. Once a pair bond is established and a territory is secured, the focus shifts to nest construction and reproduction. The choice of nest site is critical, and it is influenced by factors such as protection from weather and predators, visibility of the surrounding area, and proximity to prey. Cliff ledges are preferred in many regions because they offer these advantages, but trees are used where cliffs are not available. The nest, or eyrie, is built collaboratively, with both members of the pair contributing. Sticks and branches are gathered from the surrounding area and arranged into a platform, often with a slight depression in the center to hold the eggs. The structure is reinforced and added to each year, and old nests can become massive and highly conspicuous. The lining of the nest cup, consisting of softer materials such as grass, moss, and bark, provides a cushioned surface for the eggs and insulation for the chicks. Copulation occurs frequently in the days and weeks leading up to egg laying, often on or near the nest, and each copulatory event is brief, lasting only a few seconds. The male mounts the female from behind, and the pair brings their cloacae into contact, allowing for the transfer of sperm. Fertilization occurs internally, and the eggs are formed as they pass through the female's reproductive tract. Each egg is encased in a shell composed primarily of calcium carbonate, which is secreted by the shell gland in the oviduct. The shell provides protection for the developing embryo and allows for gas exchange, as oxygen must diffuse in and carbon dioxide must diffuse out through microscopic pores in the shell. The female lays one egg every 2 to 4 days until the clutch is complete, and then incubation begins. Incubation is primarily the responsibility of the female, though the male occasionally takes over for brief periods, allowing the female to leave the nest to feed, drink, or defecate. The female maintains the eggs at a constant temperature of around 37 to 38 degrees Celsius by sitting on them and transferring heat from a bare patch of skin on her abdomen, called the brood patch, which develops during the breeding season. The brood patch is highly vascularized, meaning it has a rich blood supply, which facilitates heat transfer. The female also turns the eggs regularly to ensure even heating and to prevent the embryo from sticking to the shell membrane. If temperatures drop, she may shiver to generate additional heat, and if temperatures rise, she may shade the eggs with her wings or temporarily leave the nest to allow cooling. Inside the egg, the embryo undergoes a series of developmental stages, transforming from a single fertilized cell into a fully formed chick. The yolk provides nutrients, and the albumin, or egg white, provides water and additional protein. A system of membranes, including the amnion, chorion, and allantois, surrounds the embryo and facilitates respiration, waste storage, and protection. As the embryo grows, it begins to move and to vocalize, producing soft peeping sounds that can be heard through the shell. These sounds may serve as a form of communication between the chick and the parents, signaling that development is progressing and hatching is imminent. The chick uses a specialized egg tooth, a small, hard projection on the tip of the beak, to pip or crack the shell. Pipping typically begins with a small hole in the shell, and over the course of 1 to 2 days, the chick gradually enlarges the hole and breaks free from the shell. The egg tooth falls off shortly after hatching, as it is no longer needed. Newly hatched chicks are semi-altricial, meaning they are downy, have their eyes open, and can move about the nest, but they are unable to regulate their body temperature and depend entirely on the parents for warmth and food. The chicks grow rapidly, doubling or even tripling their weight in the first week of life. The female broods them almost continuously, maintaining their body temperature and protecting them from sun, rain, and predators. The male provides food, delivering prey to the nest at regular intervals. The female tears the prey into small, easily digestible pieces and offers them to the chicks, which gape and beg with open mouths and insistent calls. The chicks are highly competitive, and the older, larger chick often dominates access to food, shoving the younger chick aside or even attacking it. This sibling competition can result in the death of the younger chick, a phenomenon observed in many raptor species. The adaptive significance of this behavior is thought to be related to resource availability. In years when prey is abundant, both chicks can be fed adequately and both may survive. But in years of scarcity, it is better to ensure the survival of one strong chick than to raise two weak ones. As the chicks grow, their down is replaced by juvenile plumage, and they begin to develop the physical and behavioral traits they will need for independence. They exercise their wings, flapping vigorously while standing on the nest, and they practice gripping and manipulating objects with their feet. They also begin to feed themselves, tearing into prey brought by the parents rather than waiting to be fed. By the time they are ready to fledge, they are nearly as large as the adults, though they are distinguishable by their plumage and by their less refined flying skills. The first flight from the nest is a major milestone, and it is often tentative and awkward. The fledgling may flutter to a nearby ledge or tree, or it may glide down to the ground. Once airborne, however, the fledgling quickly gains confidence and proficiency, and within days it is flying with increasing skill. The post-fledging period is a time of learning and development. The parents continue to provide food, often for 2 to 3 months after fledging, during which time the young eagle learns to hunt. This learning process is gradual and involves both observation and experimentation. The young eagle watches the parents hunt, noting their techniques, and then attempts to replicate those behaviors. Early hunting attempts are often unsuccessful, and the young eagle may miss prey, misjudge distances, or fail to make a kill. Over time, however, skills improve and success rates increase. Hunting is a complex skill that requires precise coordination of visual perception, flight control, and motor execution, and it takes weeks or months of practice to master. During this period, the young eagle is still dependent on the parents for much of its food, and without their continued support, it would likely starve. Eventually, the young eagle reaches a point where it is capable of sustained independent hunting, and at this time, the parents begin to reduce the frequency of food deliveries. The young eagle also begins to explore areas beyond the immediate vicinity of the nest, gradually expanding its range and gaining knowledge of the broader landscape. This dispersal phase is driven by a combination of factors, including parental aggression, the search for food, and the innate drive to find a territory of its own. Dispersing eagles often wander widely, covering hundreds or even thousands of kilometers over the course of months or years. This wandering brings them into unfamiliar areas and exposes them to a wide range of habitats, prey species, and hazards. Mortality rates are high during this period, and many young eagles do not survive to establish a territory and breed. Those that do survive face the challenge of finding an unoccupied territory or of displacing an established territory holder. This is no easy task, as high-quality territories are limited and are fiercely defended. Young eagles may spend several years as floaters, living a nomadic existence and opportunistically exploiting temporary food sources, before they successfully establish a territory. Once a territory is secured, the eagle must then find a mate, and this, too, can take time. Unmated eagles may remain on their territories, advertising their presence through displays and vocalizations, in the hope of attracting a mate. Alternatively, they may wander in search of potential partners, attending feeding aggregations and other locations where eagles congregate. Once a pair bond is formed, the cycle of reproduction begins anew, and the eagle takes on the role of parent, investing its energy and resources into the next generation. The lifespan of a golden eagle is shaped by a multitude of factors, including genetics, environmental conditions, prey availability, disease, parasites, predation, and human impacts. In the wild, survival is uncertain, and death can come from many sources. Nestlings and fledglings face predation, starvation, accidents, and adverse weather. Juveniles and subadults face the challenges of learning to hunt, competing for resources, and avoiding hazards such as collisions and poisoning. Adults, once established, have relatively high survival rates, but they are not immune to threats. Injury, disease, starvation, and human-caused mortality can all cut short the life of an adult eagle. Despite these risks, some individuals live for decades, successfully raising multiple broods and passing on their genes to numerous offspring. These long-lived individuals are the foundation of stable eagle populations, and their survival is critical for population persistence. The genetic diversity of golden eagle populations is maintained through dispersal, gene flow, and the mixing of individuals from different lineages. Dispersing young eagles often travel long distances, sometimes crossing mountain ranges or bodies of water, and this movement facilitates the exchange of genes between populations. Gene flow helps to prevent inbreeding, which can lead to reduced fitness and increased vulnerability to disease and environmental change. However, in regions where populations are small, isolated, or fragmented, gene flow may be limited, leading to genetic bottlenecks and loss of diversity. Conservation efforts that maintain connectivity between populations, such as protecting migration corridors and restoring habitat, are important for preserving genetic diversity and ensuring the long-term viability of the species. The evolutionary history of the golden eagle is a story of adaptation, diversification, and survival over millions of years. The genus Aquila, to which I belong, is thought to have originated in Eurasia during the late Miocene or early Pliocene, roughly 5 to 10 million years ago. Fossil evidence of early Aquila species has been found in Europe and Asia, and these ancestral eagles were likely similar in size and ecology to modern species. Over time, the genus diversified, giving rise to multiple species that occupy a range of habitats from deserts to mountains to steppes. The golden eagle, Aquila cressidos, emerged as a distinct species during the Pleistocene, a period characterized by repeated glaciations and dramatic shifts in climate and vegetation. These environmental changes shaped the evolution of many species, including mine, driving adaptations for survival in cold, open landscapes, and for exploiting a diverse array of prey. Molecular genetic studies have provided insights into the relationships among golden eagle populations and the timing of their divergence. These studies suggest that there is relatively low genetic differentiation among populations across much of the species range, indicating that gene flow has been high and that populations have remained connected over evolutionary time. However, some regional populations, particularly those in isolated areas such as islands or highly fragmented habitats, show greater genetic distinctiveness. Understanding the genetic structure of golden eagle populations is important for conservation, as it helps identify populations that may be at risk due to small size or isolation, and informs decisions about where to focus conservation efforts. The relationship between golden eagles and humans has been shaped by cultural, economic, and ecological factors, and it has varied widely across time and space. In many cultures, I have been revered as a symbol of power, bravery, and spiritual significance. Indigenous peoples in North America, including tribes such as the Lakota, the Hopi, and the Tlingit, have long incorporated eagle feathers, talons, and bones into ceremonial objects, regalia, and rituals. Eagle feathers are considered sacred and are used in religious ceremonies, dances, and as symbols of honor and achievement. The taking of eagles and eagle feathers is regulated by law in the United States, and permits are issued to enrolled members of federally recognized tribes for religious and cultural purposes. In Central Asia, golden eagles have been used in falconry for centuries, and this practice continues today, particularly in Kazakhstan, Kyrgyzstan, and Mongolia. Burkachi, the eagle hunters of these regions, train golden eagles to hunt foxes, hares, and even wolves, and the practice is both a cultural tradition and a practical means of obtaining food and furs. In European folklore and heraldry, the eagle has long been a symbol of power and sovereignty, featured on coats of arms, flags, and emblems of empires and nations. The golden eagle has been associated with gods and heroes in mythology, such as the eagle of Zeus in Greek mythology and the eagle of Odin in Norse mythology. This symbolic significance has contributed to a complex relationship, one in which eagles are both admired and feared, protected and persecuted. The persecution of golden eagles reached its peak during the 19th and 20th centuries, driven by the belief that eagles posed a significant threat to livestock and game animals. Bounties were offered for dead eagles, and thousands were killed through shooting, trapping, and poisoning. In some regions, populations declined to critically low levels or were extirpated entirely. The shift toward legal protection and conservation of golden eagles began in the mid-20th century, spurred by changing societal attitudes toward wildlife, the rise of the environmental movement, and growing scientific evidence that eagles played important ecological roles, and that their impact on livestock and game was often overstated. In the United States, the Bald and Golden Eagle Protection Act was enacted in 1940 for bald eagles, and was extended to golden eagles in 1962, making it illegal to kill, harass, or possess eagles without a permit. Similar protections have been enacted in many other countries, and international agreements such as the Convention on Biological Diversity and the Convention on the Conservation of Migratory Species of Wild Animals provide additional frameworks for conservation. These legal protections have been instrumental in allowing golden eagle populations to recover in many regions, though challenges remain. Public education and outreach are critical components of golden eagle conservation, as they help to build support for protective measures and to address misconceptions and conflicts. Many people are unaware of the ecological role of eagles or the threats they face, and educational programs can provide this information in accessible and engaging ways. Outreach to specific groups, such as ranchers, hunters, and energy developers, can help to reduce conflicts and to promote coexistence. For example, programs that demonstrate the use of non-lethal deterrents to protect livestock, that provide information about the limited impact of eagles on game populations, or that offer incentives for avoiding eagle habitats in development projects, can be highly effective. Citizen science programs that engage the public in monitoring eagle populations, such as nest surveys or migration counts, also contribute to conservation by generating valuable data and by fostering a sense of stewardship and connection to wildlife. The future of golden eagles is intertwined with the broader challenge of conserving biodiversity in an era of rapid environmental change. The pressures of human population growth, resource extraction, climate change, and habitat loss are unprecedented, and they pose significant threats to eagles and countless other species. However, there is also reason for optimism. Advances in science and technology are providing new tools for monitoring and managing wildlife populations, from satellite tracking and genetic analysis to remote sensing and machine learning. Conservation successes, such as the recovery of golden eagle populations in many regions, demonstrate that with sufficient effort and resources, it is possible to reverse declines and to restore species to healthy levels. The growing recognition of the intrinsic value of wildlife and the importance of intact ecosystems for human well-being is driving increased investment in conservation and a greater willingness to address the root causes of biodiversity loss. I am both a beneficiary and a symbol of these efforts. My presence in the sky is a reminder of the wildness and beauty of the natural world, and a testament to the resilience of life in the face of adversity. My survival depends on the actions of people who care about the future of the planet and who are willing to make the difficult choices necessary to protect it. As I soar over the landscapes I call home, I am a witness to the changes unfolding around me, and I am a participant in the ongoing story of evolution, adaptation, and survival that has defined life on Earth for billions of years. My story is far from over, and the chapters yet to be written will depend on the choices made by the human communities with whom I share this world. The path forward is uncertain, but the potential for coexistence and for a future in which golden eagles and humans thrive together is real, and it is worth striving for.